Okay, let's dive into this. You know, if you're a clinician, you've been there. You're staring at an ECG, an electrocardiogram, and the heartbeat is just all over the place. What we call an irregularly irregular rhythm. And the big question hits you immediately. What on earth is causing this? You have to make the right call and fast. It's absolutely critical. So you see a rhythm that looks something like this. The beats just aren't in sync, right? They're chaotic. This is such a common sight in a hospital or a clinic, but it always raises that same critical question. Your diagnosis, what you decide in that moment, is going to dictate the entire treatment plan, and that can have some pretty huge consequences for the patient. Now, the top suspect is almost always atrial fibrillation, AF for short. It's the most common arrhythmia out there. But what if it's not? What if it's a mimic? Something like, say, multifocal atrial tachycardia. Being able to tell the difference is crucial, and today we're going to look at a hidden clue that helps us do just that. And that clue? Well, it's the hero of our story today. It's called the Shora sign. It's this subtle but really powerful pattern that's kind of hiding in plain sight on the ECG, and it's the key to unlocking this whole diagnostic mystery. So what is it exactly? Well, the Shora sign is all about the QRS complex, that big spike you see on the ECG. Specifically, it's a noticeable change in the height, or the voltage, of these spikes from one beat to the very next. What you're looking for is a change of more than zero point 0.1 millivolts, and you need to see it across 3 or more beats in a row. It's basically a telltale sign of electrical instability. Okay, so we know the definition. But now let's break down what this sign actually looks like on a rhythm strip, and more importantly, what it tells us about the electrical chaos that's happening inside the heart. This image just lays it out perfectly. First, check out the baseline. See how there aren't any clear P waves? It's just a chaotic, kind of squiggly line. We call those fibrillatory waves. That's our first clue. It tells us the atria, the heart's upper chambers, are basically just quivering instead of pumping properly. And because of that, the ventricles, right below them, fill up with different amounts of blood each time, which leads to this, the visible up and down change in the height of the QRS complexes. That right there is the Shora sign. And this term, it just brilliantly illustrates what's going on under the hood, electromechanical chaos. The electrical signals in the atria are a complete mess, right? And that mechanical dysfunction, the fact that the ventricles are filling up so variably, is reflected directly in the changing electrical voltage of the QRS. The two things are completely linked. So here's the crucial part. How do we actually use this sign? Well, let's put it to the test in a classic diagnostic showdown. Atrial fibrillation versus its notorious mimic, multifocal atrial tachycardia, or MAT. They're both irregularly irregular rhythms, but only one of them truly has this deep electromechanical chaos. I mean, just look at the difference here. It's night and day. On the left, in atrial fibrillation, you can see the QRS heights are all over the map. You've got big spikes, little spikes, it's total variability. But now look over to the right at MAT. Yeah, the rhythm is still irregular, for sure, but the QRS amplitudes, they're much more consistent. There's an underlying organization there that AF just doesn't have. And we can actually put a number on this visual difference. There's something called the Shora Variability Index, or SVI. For atrial fibrillation, the average SVI is pretty high. It's around 48.7. This number basically quantifies that visual chaos we were just looking at. And in contrast, wow, the SVI from multifocal atrial tachycardia is dramatically lower, only around 13.8. This huge numerical difference gives us a powerful, objective way to tell these two apart. It takes what feels like a subjective guess and turns it into hard data. So let's just recap this key distinction, because it's important. AF gives you that high QRS voltage variability because of the electromechanical chaos. MAT, on the other hand, has low variability because even though you have multiple pacemakers firing off, there's still some preserved atrial organization. It's like chaos versus a slightly disorganized committee meeting. So what does this all mean when you're at the bedside with a patient? Why does spotting this one little sign actually matter for patient care? Let's get to the clinical verdict. The Shora sign is a really sensitive tool. It helps you confirm an AF diagnosis with a much higher degree of confidence, and it's an absolute lifesaver in those tricky cases where the classic fibrillatory waves are really subtle and hard to see. It just gives clinicians a reliable way to cut through the noise and tell AF apart from its mimics, which means you get to the right treatment plan faster. And what's really exciting is that technology is making this even easier to use. People are developing tools, like this app concept here, that could potentially analyze an ECG strip and calculate that Shora variability index for you automatically. I mean, think about it. This could put expert-level diagnostics into the hands of way more healthcare providers, no matter where they are. So this all leaves us with a really fascinating final thought. We've gone from just kind of a subjective glance at a rhythm strip to a quantifiable, data-driven clue. It really makes you wonder, right? How will other precise, hidden signs, just like this one, continue to change the future of how we diagnose and really how we understand the complex rhythms of the human heart?